Hi, I'm going to teach you how to love physics, and that happens when you learn how to understand physics. Well, if you were able to digest the last video I made about the basic addition of vectors by components, I have to tell you, I made things way too simple. I was only using vectors pointed in the upper right quadrant of the Cartesian axis. What makes this too simple is that all the components are pointed in the positive direction. So it was just a simple matter of addition. However, in reality, you will be dealing with vectors pointing in all sorts of directions. So this method needs to be appended to address multiple directions. The whole point is that in the situation where vectors are pointing in opposite directions, we need to be able to reliably address the different directionality that results. In physics, the easiest way to address things with opposite directions is by using opposite signs for each item. This is the establishment of sign convention. The fun thing about imposing a sign convention is that it is entirely arbitrary. Usually you will use down as negative, but there will be times when it is convenient to choose down to be positive. The only danger comes when you are not consistent with your sign convention within one given problem. I will use in this video, and most of the time, the sign convention that corresponds to the usual Cartesian axis. That means I will assign an x component as positive if it is pointing to the right or to the positive x-axis, and negative if it is pointing to the left or to the negative x-axis. I will assign a y component positive if it is pointing up, and negative if it is pointing down. Notice that the sign of the component tells you absolutely nothing about the magnitude of the component. The only information that signs will ever reveal is direction. Now I choose to put this information in the following way. Take this vector r with magnitude 5 at 210 degrees from the positive x-axis. I want to break it into components. So first I superimpose the Cartesian axis over the vector r. The first question that comes to mind is which angle to use to get the components. Well, the components are the two vectors that are parallel to the two axes respectively and that add up to r. Pictorially, you can see that these are the only two vectors that fit that bill. They form a right triangle with r as the hypotenuse, so that using trigonometry to obtain their respective magnitudes, we must use an angle inside the triangle. Notice how it makes no sense to use the angle that was given, since the angle is not inside the triangle. Instead, you have to use this angle between r and the x-axis. That angle can be obtained from the one given by subtracting two known angles. 210 minus 180 gives 30 degrees. So we get the magnitude of r sub x is 5 cosine 30 equals 2.5. And the magnitude of r sub y is 5 sine 30 equals 4.3. Notice that we have only discussed the magnitude, and since magnitude is naturally a positive number, we have positive signs on them. Now to apply the sign convention, this means we will encode the information of the directionality onto the positive magnitudes. So we may or may not still be dealing with positive numbers. R sub x is pointing to the left, or in the negative x direction, so we attach a negative sign to r sub x. And r sub y is pointing down. That is the negative y direction, so we also attach a negative sign to r sub y. Now I will update the algorithm of adding vectors by components from the last video to include this sign convention. To add any two vectors, you first need to break each vector into components. To break each vector into components, simply superimpose the Cartesian axes over each vector individually with the origin at the tail. Form the right triangle with the two vectors parallel to each respective axis. Get the magnitudes of the two sides by the trigonometry of that triangle. Determine the sign of the component by applying the sign convention. Typically we use up and right as positive and down and left as negative. Do this for all the vectors in the sum, and then add up the components to get the components of the resultant vector. Notice this can work for addition of 2, 3, 4, 5, any number of vectors. If the vectors are in different directions, the sign convention naturally absorbs the subtraction into the calculation. So using a sign convention consistently allows for simplicity in actual calculations, since you don't have to worry about which vector is being subtracted from what. That information is taken into account easily when you just apply consistent sign convention onto all of the components. Once again, proficiency at vector addition is something you want to acquire early on in your physics career. So do practice until you are able to do this with any number of vectors with minimal effort. You probably don't want to do extra work, but you really should try doing more of these problems than are assigned in your homework to gain maximum proficiency at this task. So, once again, thanks for listening, and leave any questions you have down in the comments section.